This video will be practice problems on linear approximations. This is one specific application of the derivative. Okay, so if you haven't seen my short, I'll try to remember to link it, but the point I made in that short is the key idea of how we should be thinking about these problems. The linear approximation, you might be intimidated by, oh, it's another formula to memorize. However, if you really understand where the formula came from, it's really no different. It's the exact same thing, actually, as the equation of the tangent line. Linear approximation is the exact same thing as the equation of the tangent line. They just moved one term to the other side of the equation. That's really it. Okay, so whenever they ask for a linear approximation, it's no different than finding the slope of the tangent line, which you probably are very comfortable doing. Okay? Don't get intimidated by when I ask linear approximation and being intimidated by what's the formula? I don't remember. It's exact same thing, literally exact same thing as the slope of the tangent equation of the tangent line. Okay, so we'll see how that manifests itself in some problems. Number one, function f of x meets its tangent line at the point a f of a. What is the equation of the linear approximation to f at x is equal to a? Okay, so hopefully you tried this one, and if you got the point I made in the beginning of this video, you just have to find the equation of the tangent line. That's it to this question. Okay, so that's the key point once again. So this is in point slope form, y minus the y coordinate. Well, the y coordinate is just f of a. Okay, and the x coordinate will be a. So f prime of a is the slope of the tangent line, right? This is slope right here times x minus the x coordinate, which we said was a. And then this is where the linear approximation formula is. They just move this f of a to the right-hand side. And they call this, like in some textbooks, I remember, it calls it L of x. Linear approximation is this, but you see is the exact same thing as the slope of the tangent line. I keep repeating myself here because I want you to remember that. Okay, number two, use a linear approximation centered at 2 to estimate j of 2.14 if j of x is this guy here. We need a calculator for this one. So go ahead and try this first on your own. So we're going to want the equation of the tangent line at, this should be a t, not x. I don't know why I didn't catch that. At t is equal to 2. Okay, so this should be a t as well over here, but everything should be a t. Let me fix that now before I move on. Okay, this is a t, and this should be a t. I should just change everything to x, but I'm assuming the book had it as a t. Okay, this should be fine. Sorry about that. Okay, so as I was saying, we need the equation of the tangent line at t equals 2. This should be a t as well. Okay, so what do we need? We need a slope and a point. How do we get the slope? It's the derivative. So we need j prime of 2, which you can use your calculator and derive y1 comma x comma 2. All right, or we can do it by hand. It's not that bad. You should get 26.25. Okay, I showed the work here, but if you know how to use your calculator, much faster because this one calculator was allowed. Or I said required actually. Okay, so we have the slope. We need a point. So the point will be 2 comma j of 2. Okay, so we have all the components for the equation of the line. We need slope and a point. So I put it in point slope form. Y minus j of 2 is 26.25 times t minus 2. So just rewrite this, move this j of 2 onto the other side. And then this is the exact value, I guess. So this is it right here, the equation of the tangent line right here. Okay, so we're going to use this tangent line to approximate j of 2.14, okay? So we're going to plug in 2.14 right into this equation right here, where t is 2.14, okay? And you should get 22.1976 after that, okay? Again, I would recommend you watch the short to understand how to use the linear approximation. and why we're using it to approximate a nearby point. I explained it in the short. Okay, if h of 0 equals 4 and h prime of 0 is -5, so there's extra spacing here for some reason, okay, use a linear approximation to estimate h of 0.25. Okay, so hopefully you try this yourself. So what do we need to do? We need to find the equation of the tangent line at x is equal to 0, because the center of the linear approximation is 0. Why do we choose 0? Well, 0 is very close to 0.25. That's why. Okay. So the equation of the tangent line, we have a slope and we have a point already. So y minus 4, this is point slope form, equals -5 times x minus 0. This is how you know I'm picky and pay attention to details, careful attention to details. The extra spacing was annoying me. But anyway, okay, so we can rewrite this as minus 5x plus 4, okay? So now we're going to use this equation of the tangent line to approximate h of 0.25. Plug in x as 0.25, okay? Problem 4, if g of x is a continuous and differentiable function and contains the values given in the table, estimate g prime of 2 with a linear approximation. Okay, so again, we need equation of a tangent line. And where do we want it centered at? Where do we want the equation of tangent line? Probably at x is equal to 3. Okay, so we need g prime of 3. We need a slope, we need a point. We have a point, 3 and -1/2, but we need a slope. So we got to estimate the slope with a nearby point. Okay, so that's what I did here. I guess I chose this point over here, 5/2 minus 7/4. Okay, so g prime is about 5/2. So then we can get the equation of the tangent line because we have a slope here and we have a point up here. Okay, so the equation is right here. And then therefore, we can approximate the g of 3.2 by this tangent line. So plug in x as 3.2 and we get g of 3.2 is approximately 0. Okay, so this one probably actually I marked calculator required or something like that. And so we can do this by hand also. All right, that's it for this video. Again, the key point, once again, that I want you to take away from this video is the linear approximation, exact same thing as the equation of the tangent line. Hopefully this was helpful. Please give this video a like if it did help you. And hopefully I see you in another video as well. Bye.